Today we are going to be graphing, and today's graphing is going to be a little different than the graphing we've done in the past, and that's because we're going to have shading involved. So let's just start looking at what we have here. Example 1 says look at the graph, choose 3 points. So first I want to pick a point above the line. So this is considered to be above the line, and I can pick any point above the line. I like to pick points, that are really easy to work with. So I'm going to pick the point 0, 0, because that's above the line, and I love working with zeros because they're very easy to work with. Okay, so the next thing says plug the point into the following statement and complete the statement. Since this x coordinate right here is a 0, I'm going to put 0 into that x. Then I'll recopy the minus 3. Since the y coordinate is 0, I'm going to put 0 into the y. Working this right-hand side out, 2 times 0 is 0. 0 minus 3 is negative 3. I'm going to bring down my 0. And what we're looking for here is, does 0 equal negative 3? Nope. Is 0 greater than negative 3? Or is 0 less than negative 3? 0 is greater than negative 3. So that's the symbol we want to put there. And I'll make this make sense here in just a little bit. Okay, number 2 says pick a point below the line. So I can pick any point I want as long as it's below the line. So I can use anything I want. I'm just going to pick something that I think is pretty easy. So this is 1, 2, 3. This is the point 3, 0, because you're right 3 and not up or down. And like I said, you can pick any point you want. I could pick something down here, down here, down here. Doesn't matter. Okay, and I'm going to do what I did just a minute ago. This 3 here is the x coordinate, so I'm going to put 3 into this x. And then I'll just recopy the minus 3 in the back. 0 is the y coordinate, so I'm going to put 0 into the y. And now I'm going to work this right-hand side out. 2 times 3 is 6. 6 minus 3 is 3. I'm going to bring down my 0. And now I'm trying to figure out what my statement should say. Does 0 equal 3? No. Is 0 less than 3? No. No? Yes? Is 0 greater than 3? 0 is less than 3. Okay? And looking at number 3. A point on the line. Okay, this time I actually want to pick a point that is physically on the line, and it can be any point that I want it to be, but I want to pick something nice. So I kind of look where the line goes through a corner of a box. So I don't want to pick like right here, because that's not a corner of a box, and I don't know exactly what that would be. I'd have to estimate. So I'm going to use this point right here. So I don't go right or left, I just drop 3. So my x coordinate 0 and my y coordinate's negative 3. So that's the point I want to pick. 0, negative 3. Okay, now let's plug it in. 0 is the x coordinate, so I'm going to put 0 into that x and recopy the minus 3. Negative 3 is the y coordinate, so I'm going to put negative 3 into the y. And then I'm going to work out this side over here. 2 times 0 is 0. 0 minus 3 is negative 3. And then I drop that negative 3. And then I'm just trying to figure out what's going on here. And what do you think? Negative 3 equals negative 3. So let's talk about what's going on here. This is the guy that I actually want to graph. This is my ultimate goal here. This is the line that I want to graph. So let's look at some things that happen here. I can see that when I get a point above the line, that's a greater than symbol. When I picked a point below the line, I got a less than symbol. And when I picked a point exactly on the line, I got an equals. So what that means is, if we ever see a less than symbol, we want to look for we want to shade below the line. So we want to shade below the line. And just to make that make sense again, when I picked this point right here that was below the line, it was a less than symbol. When I picked this point right here that was above the line, it was a greater than symbol. So if I see a greater than symbol, I'm going to shade above the line. Less than, you shade below. Greater than, you shade above. Okay, what this other part wants to know is what kind of line is it going to be? If there's an equals, it's going to be a solid line. Here's an equals, so it's going to be a solid line. Like before when we saw the equals, we had a solid circle on our number line. If there's not an equals, it's going to be a dotted or a dashed line, however you like to say it. So here there's no equal symbol, so it's going to be a dotted or a dashed line. And when we were graphing on our number lines, this is when we had an open circle. With the equals, that was our solid circles, and when we didn't have the equals, those were our open circles. Okay, and so looking at this example here, I know that this is the same line as up above, but I just kind of want to practice our graphing again. Since this is already in slope-intercept form, it's ready to go. First thing I always plot is our y-intercept, and our y-intercept is the number in the back. So first I'm going to plot -3 on the y-axis. My slope is the number that's in front of the x, so my slope is 2 over 1. So that's up 2, right 1, up 2, right 1, up 2, right 1. Because of the equals, it's going to be a solid line. And because of the less than, I'm going to shade below my line. So what this means is every single point that is in this green shaded section, and of course it goes on to infinity, is an answer to this problem. If I picked this point and plugged it into the equation, it'd give me a true statement. If I pick this point and plug it in the equation, it'd give me a true statement. So all of the points in the shaded area are answers to this problem. And every point that's on the line is also an answer because of the equals and because of the solid line. Now if this was a dashed line, points on the line wouldn't be answers. But because it's a solid line, this would be an answer, 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 answer. Okay, so just running through it again. Less than, we shade below the line. Greater than, we shade above the line. If there's an equals, it's a solid line. If there's no equals, it's a dashed line. Okay, let's practice. Okay, these I need to make sure that they are in slope-intercept form first, and I can see that this one is not. So I'm going to circle everything, smush with my y. Whatever's outside my circle, I'm going to add or subtract. So I am going to get rid of that minus 2x by adding 2x. So I'm going to add 2x to both sides. The 3y drops, my symbol drops. I can't actually add these, so I'm going to recopy the positive 2x and then the positive 6. And then I divide by whatever's up against the y. So I divide both sides by 3. Because I'm dividing by a positive number, I do not flip the inequality sign, so that stays the same. 2/3 doesn't reduce, so that stays 2/3 x. And 6 over 3 reduces to 2. Okay, first thing I plot is my y-intercept, and my y-intercept is this number in the back. So I'm going to plot 2 on my y-axis. My slope is 2 over 3, so that's up 2 and right 3, up 2 and right 3, or I can go down 2 and left 3. Because there's no equals, this is going to be a dashed line. And because it's a greater than symbol, I shade above. So anything above the line is an answer. So all of this to infinity on up. Okay, now the next thing says decide if the points are in the solution set. I could do this a couple ways. I could do it like kind of how I did it earlier. The -2 is the x coordinate, so I could put -2 in the x. 2 is the y coordinate, so I could put 2 in the y, and I could work it out and see if I get a true statement or a false statement. If I get a true statement, it's a solution. If I get a false statement, it's not a solution. Or I can just go to negative 2, 2 on the graph. So I go left 2 and up 2. Is negative 2, 2 in the shaded section? Yes. So since it's in the shaded section, then it is a solution. And I'm just going to show you the other way that I could do it. So I'm going to put this 2 in that y. So it would say 3 times 2 minus, I'm going to put negative 2 in that x. And I'm going to see if this does give me something greater than 6. 3 times 2 is 6. Negative 2 times negative 2 is a positive 4. 6 plus 4 is 10. And is 10 greater than 6? Yes. That's another way to know that it's a solution. You can either plug the x-coordinate in the x, the y-coordinate in the y, and work it out, or you can plot the point and see if it's in your shaded section. Okay, let's look at the point 3, 4. So I'm going to go right 3 and up 4. 1, 2, 3, 4. That point is on my line, but is my line a solid line? No. Since my line is not a solid line, the answer is no. Since this is a dashed line, that means the points on the line actually are not answers. So it's a no. And of course, I could always verify it the other way. I could put the 3 in the x, and I could put the 4 in the y, and work it out. Okay, let's look at number 4. This one, I need to make sure I solve for y, so I circle everything smushed with it. Whatever is outside the circle, I add or subtract. So I'm going to subtract x from both sides. My negative 3y is going to drop, so is my symbol. And then I rewrite this a negative x minus 6. And then I divide by whatever's smushed with my y, so I divide both sides by negative 3. Because I'm dividing by a negative, I have to flip my inequality sign around. Flip. And then don't forget there's a 1 in front of this, you just don't see it. So if I reduce, a negative over a negative makes a positive, and you can't reduce 1/3, so it stays 1/3 x. And negative 6 over negative 3 makes positive 2. So just remember, if you divide by a negative, you have to flip that inequality sign. Okay, let's graph. The y-intercept is a positive 2, so I'm going to plot 2 on my y-axis. My slope is 1/3, so that's up 1 and right 3, up 1, right 3, up 1, right 3, or I can go down 1 and left 3. Because there's an equals, it's going to be a solid line. And because it's less than, it's going to go below my line. So everything below my line is going to be an answer. Okay, first thing I want to check is 0, 4. So the x-coordinate 0, the y-coordinate's 4. That means don't go right or left, go up 4. Is 0, 4 in the shaded section? No. So it's not an answer. It has to be in the shaded section to be a solution. 0, 0. That's right here. Is 0, 0 in the shaded section? Yes. So that is an answer. And also this time, because I have a solid line, every point on the line would also be a solution. Okay, number 5. This is not a diagonal line because there's not an x and a y in the equation. So remember, y equals lines, they cross only the y-axis. So first I go to where my y is a 3. So that's up 3. And I want to draw a line that only crosses the y-axis. So it's going to look like this. Because there's no equals, it will be a dashed line. And here, I just use common sense. Whenever I draw a horizontal or a vertical line, I just use common sense when it comes to shading. Where are your y's greater than 3? Above the line or below? Where are your y's greater than 3? Above the line. Okay, let's see if these guys over here are solutions. 1, 3. I go right 1 and up 3. That's on the line. Is my line a solid line? Nope. So the answer is no. It's on the line, but because the line is dashed, then it's not a solution. Okay, negative 3, 6. I go left 3, and I go up 6. 1, 2, 3, 4, 5, 6. Is that in my shaded section? Yes, it is. So I know it's a solution. Okay, this next one is not a diagonal line either, because there's not an x and a y. So I go to where my x is negative 4. So I move to the left 4. I want my line to only cross my x-axis, so I know it's going to be vertical. Because of the equals, it is a solid line. And like I said a minute ago, I like to use common sense when I'm shading my horizontal and vertical lines. Where are your x's less than -4? To the right or to the left? Where are your x's less than -4? To the left. Okay, let's see if these 2 points are solutions. -4, -2, I go left 4 and down 2. That point's on the line. Is it a solution? Yes, because this time I have a solid line. 6, 1, I go right 6 and up 1. Is that in the shaded section? Nope, so it's not an answer. Okay, and last one. Says, which of the following points would be solutions to the inequality y greater than 2/3 x plus 2? Because I don't have this graphed, I'm going to actually plug these in and see if I get true statements. 6 is the x, 0 is the y. So I'm going to put 0 into this y, recopy the greater than, 2/3. Where the x is, I'm going to put in the 6, and I'm going to pop that over 1, and recopy plus 2. If I multiply straight across, I get 12 over 3. And what does 12 over 3 reduce to be? 12 over 3 makes 4. So I have 0 greater than 4 plus 2. 4 plus 2 is 6. Is 0 greater than 6? No. So the answer to this is no. If you get a false statement, the answer is no. This point is not a solution to this graph. Visually, that means if I graphed this line, 6, 0 would not be in the shaded section. Okay, let's try another one. -6 is the x, 0 is the y. So I'm going to put 0 into the y. I'm going to put -6 into the x. And I'm going to recopy the plus 2. So this time I get -12 over 3. -12 over 3 makes -4. -4 plus 2 makes -2. Is 0 greater than -2? Yes. So this time the answer is yes, it's a solution. So visually, if I were to graph this line, I would see this point in the shaded section. Last one, -9, that's our x. -3, that's our y. So -3 goes into the y. -9 goes into the x. And I recopy plus 2. If I multiply straight across, I get -18 over 3. And what's -18 over 3? -6. Recopy the plus 2, the symbol in the -3. -6 plus 2 makes -4. And is -3 greater than -4? Yes. So this point is also a solution to this equation. That's all for me, folks. Smiley face. Thank you.